All right, we are looking at multiplying matrices again here. And we have two matrices here. We have a 2 by 2 matrix. And this is its size or its dimensions. And we have another 2 by 2 matrix. Now, when we multiply a 2 by 2 and a 2 by 2, we're going to get another 2 by 2 matrix out. And when we're done with this one, starting the next one, I'll explain why that works. But we're just going to start with this one and then do it. So again, as we do matrix multiplication, we're always doing a row, the row of the first, or the row of, one of the rows of the first times one of the columns of the second, and where those two things intersect is going to be the new point in the new matrix. So we have our first row times first column, and that's going to get us our first element in the new matrix. So we have 1 times 5. So 1 times 5, those are the first elements, and 3 times 6. 1 times 5 is 5. 3 times 6 is 18. And then we add them together and we get 23. So in our new matrix we have 23. Now you'll notice that here I have this crossed off. I had it written wrong. So if your page that you're looking at has it wrong, just fix it. I think I corrected it there already though. It should be element 1, 2. So we have row 1, column 2, right? Even it says it here in the name, right? Row 1, column 2. So we have 1 times 7 plus the second element 3 times 8. So that is 7 plus 24, which is 31. Then we're going down to the second row, back to the first column. The first element here is 2 times the first in the row, which is 5, plus 4 times 6. That's 10 plus 24, which is 34, and that gives us our third element. And then on the last element, it is second row, second column. So I get 2 times 7 plus second part is 4 and 8 plus 4 times 8, that's 14 plus 32 is 46. And that is our answer. So the answer is this 2 by 2 matrix. Row 1 is 23 and 31. Row 2 is 34 and 46. Here we're looking at a second matrix. So this is a 2 by 3, 2 rows by 3 columns, and 3 rows by 2 columns. And what we're going to get out here is a 2 by 2. So this is possible, and we get out a 2 by 2. Now, on the ones that we've looked at, what you should notice is that the second number of the first and the first number of the second have to be the same. So they are both 3 here. The better way to say that would be the columns of the first and the rows of the second have to be the same. So these are both 3, they could both be 5, they could both be 8, but as long as they're the same. And then what size our matrix is at the end is that first and last number. we get a 2 by 2. So if I had a 1 by 3 and I wanted to multiply it by a 3 by 7, right? I would look to see that these two numbers are the same, so I can do it, and I would get out a 1 by 7, the first and the last. If I wanted to multiply a 2 by 5 and a 5 by 1, right? Again, these two middle numbers are the same. Again, better would be to say the columns of the first is the same as the rows of the second. They're the same, and so I can do it, and I get out a 2 by 1, 2 by 1. If, on the other hand, I had something like, I don't know, 2 by 4, and I wanted to multiply it by another 2 by 4, right? These two numbers, the columns of the first and the rows of the second, are not the same, right? They are not the same. Therefore, I cannot do this. This does not exist. It's not possible. All right, all of that is kind of separate, important, but separate. We're going to get a 2 by 2 out of this. So we have our row that we are going to multiply by the first column, and we get 1 times 3 plus 2 times the second element in the row, which is 4, plus the last element in the row and the last element in the column, 12 times 5. And I get 3 plus 8 plus 60, which is 71. This should be 1, 2, right? First row, second column. First row, second column, and then I'm doing the same thing. So I get 1 times the first element in the second row plus the second element in the first row times the second element in the column plus the last element in the row times the last element in the column. That's 4 plus 6 plus 24, which is 34. 2, 1. I'm going to the second row, first column. So I have 12 times 3 plus 2 times 4 plus 1 times 5. 36 plus 8 plus 5. It's 49. And lastly, this is 2, 2, row 2, column 2. So first element 12 times first element 4 plus the second element 2 times the second element 3 and the third element times the third element. So I have 28 plus 6 plus 2, and that is 36. Product, matrix dimensions. This is the possible when columns of first matrix. Match rows of second matrix. And then the dimensions are rows of first by columns of second. So again, if we had a matrix A, it has a size of 3 by 2, and we wanted to multiply it by a matrix with size 2 by 7, right? The numbers here match up, columns of the first, rows of the second, and so we can in a matrix C that is a 3 by 7. If we had two other matrices, again 1 by 3 times a 1 by 2, since these two numbers, the columns of the first and the rows of the second, are not the same, we cannot multiply them together. They do not exist.